Hey guys, it's Mrs. Hopkins, and today we're going to look at how to calculate the coefficients of regression lines and just talk a little bit about what those coefficients mean. So here we go. I'm going to open up my dossier here. All right, and the first thing that we're going to do is we're going to review a little bit about scatter plots. And scatter plots are graphs that show the relation between two quantitative variables. And what we usually do is we put the independent variable along the horizontal axis, and we put the dependent variable along the vertical axis, and we're trying to see if there is a relationship between the two, if the independent variable actually affects the dependent variable. And so if we look at these three graphs, okay, it looks like two of them might have some kind of relation and the third one doesn't. The first graph, if we kind of think about the fact that the points look like they're going uphill, we would say that this relationship would have a positive correlation. All right, the second graph, the points tend to, as x gets bigger, the y values are getting smaller, so this would have what we would call a negative correlation. All right, the third graph, they're just kind of scattered every which way. There's no pattern to them. It doesn't look like they're all going uphill or they're all going downhill. So we would say that this one has really no correlation. And so what we want to concentrate on is we want to concentrate on these lines here. Okay, we want to see if we can figure out, the equation of that line that would best describe that set of points. Right? If we see a positive or a negative correlation, we can find what's called a line of best fit. This is called our linear regression line. If we recall from algebra, we know that the equation of a line in slope-intercept form is y equals mx plus b. And remembering that the m is our slope, that is the change in our y value over the change in our x value, and the b is the y-intercept. That's the value that occurs when x is 0. Now in statistics it's very similar. We use a little different notation, but in statistics our regression line looks like this. We have a y hat equals b sub 0 plus b sub 1 times x. All right? The y hat is our predicted value. Remember that we're pulling this from a scatter plot, okay? So the predicted value is what we get when we put an x value into the problem. It may not be an actual point in our scatter plot, but it's going to be a point on our line of best fit. So this is the predicted value. All right, x is our independent variable. B1 is how the y value changes in response to x, and the b sub 0 is like our y-intercept. That's what happens when our x value is 0. So just as a quick review, the x is our independent variable. All right. The y hat is our predicted value. Okay, the coefficients are b sub 0 and b sub 1. The b sub 0 is the y-intercept, which occurs when x is 0. All right, and the b sub 1 is how fast the y hat values change with respect to x. All right, we are now going to look at how to calculate the coefficients. And so the values that we're going to need are the value of r, which I will provide to you in this problem. So we will need the r. We will need the standard deviation of the y values, standard deviation of the x values, the mean of the y values, and the mean of the x values. And so what we're gonna use to find those values is we're just going to use our calculator. So we're going to pull up our calculator. All right, and we need to put our x and our y values in there. So we're going to go to Stat. Okay, we will go to Edit. All right, and you can see that I've already put our values in. Our independent variable values will go in the L1 column, so all the x's are in the L1. The dependent variable values are going to go in L2, so we've got all the values in there. All right, once the values are put in, you go back to Stat. You go over to Calculate. We have two variables that we're looking at. So you go to Two Variable Stats, and you hit Enter. So the calculator is now asking you to verify that your X list is in L1, which it is, that your Y list is in L2, which again it is, and it's going to let us now calculate everything that we need to write our regression line. So you go down to Calculate, and you hit Enter. All right, and if you look down through the list, we have our X bar. We have our standard deviation for our X. We have our Y bar. We have our standard deviation for Y, and then I said earlier that I will provide what the R value is. So we need to write down the things that we need, make sure we get those down. X bar, standard deviation of X, Y bar, and standard deviation of Y. All right, once those are written down, we will pull up what we need. Okay, so we put our values in. Remember, to find B1, we take R, which in this case is 0.69. We multiply that by the standard deviation of Y, which is 3.31, divided by the standard deviation of X. Then I put that in on the calculator. And that gives me 1.40. To find the B sub 0, we're going to do Y bar, which is, might need to move that down a little bit. Let's see. All right, to find B sub 0, we're going to do Y bar minus B sub 1 times X bar. So we'll find out what that value is. And we end up with 20.55. Those values put into our linear equation form will give us ACT, and I always put the actual value or the actual name of the variable. So this is the ACT is like your y hat. All right. This value right here is going to be your B sub 1. This is your X. And this is your B sub 0. Okay? But like I said just a second ago, it's a good practice to go ahead and put down what those variables represent when you write your linear equation line. So we can kind of think a little bit about what this means. For this particular equation, we could say that for every 1.4 hours studying, we can expect a rise of 1 point on our ACT. That's all for today, guys. Talk to you later.